Cool. Okay, so we can see this screen here, yeah?
Yeah.
Yeah.
Cool. So it's a very similar lab to the lab we had last week, where it was 2 LANs, and I suppose you had your loopback, which is your internet connection, and you had a WAN linked in. So you had a LAN in Dublin, local area network in Dublin, and you had a LAN in Cork, and basically there was a lot of problems with it, and you had to find out all the issues and fix everything. Because I kind of said this last week, I think as well, is that it's actually more difficult for you to figure out someone else's broken network and fix it than it is to configure a brand new network from the start. So therein lies the problem, I suppose. Yeah. So there's lots of different ways when it comes to troubleshooting, and really the best way to troubleshoot is by doing. The more you troubleshoot, if you're in an environment where you're constantly fixing servers are going down or networks are going down, that's a great place to be, because you will really learn how to troubleshoot properly and effectively, and you get to your own thing. And sometimes you'll troubleshoot in one way, and then the next time it'll be a different thing. So there's no set way to troubleshooting. And another way is you can compare and contrast, and use a working config, or if there's, like, I'm not even talking about this packet tracer connection per se, but let's say there's a link down on a port on a server, on a PC, and if the server's in a cabinet, we'll connect that server to a working port on the switch. If it comes back up on the switch, well, then you know that it's a port issue on the switch. If you connected it to a working port on the switch that you know is a working port on the switch and it's still down, well, then you got to look at the server. So one of the things is you need to find, sometimes you're just going to have an issue. The server is off the network. Okay, that doesn't tell you if the issue is with the server or is with the network. Is it with the operating system of the server? Is it with a switch on the network? Where is it? So one of the things it should be doing is trying to identify the actual physical device. And then once you identify the physical device, you're halfway there, because then you can actually concentrate on that one device. There's nothing worse than having an issue that could be among a switch or a router or a server, and you have to find out, well, you have to troubleshoot all 3 devices. So the first thing you should really do is, isolate the device, try and pinpoint exactly which PC or which server or which device that the issue is happening in, and then troubleshoot accordingly. Okay, so this is just a simple example. What I will try and do is I'm going to try and do some more packet tracer files, give you an example of a broken network, and get you to fix it during the week. It'll be up in Dropbox, because it does really help you troubleshoot, and it teaches you how to troubleshoot. I think a lot of the IT courses in college, because I taught in college, I taught in DIT, a lot of the guys will come in, they've never troubleshooted before. Well, they spend a lot more time on theory than practical, but really it should be the other way around. I mean, it could be 80-20. 80% of the time is on theory and 20% is on practical, where I'd nearly say it should be more 80% on practical and 20% on theory. Anyway, okay, so so here we have the network here. I said it could be across any devices. You've got 5 problems. So basically this PC in Dublin, laptop in Dublin 1.2 should be able to ping 3.2. It could be it could be a static routing issue, it could be an issue with the laptops, it could be a gateway issue. You have to, and well, it tells you there's also a default route to the internet missing, so that tells us something there. Okay, so there's a number of ways to try and troubleshoot this. You can do what's known as follow the path. Start on the leftmost device, which is 1.2. Have a look at that, then go on to the next one, which is the router, then look at the Cork, the next, and then look at 3.2. Or you can run ping as well to see how far you get. So in this example here, you're probably better off just, because these issues are across all of these devices. So here we could start and what we could do is get the laptops out of the way first. See if the Dublin laptop is working, try and fix it. See if the Cork laptop is working, try and fix it. Now you'll know straight away if there's an issue. Click on the laptop, see if you're able to ping the local default gateway. So I actually just remove this here. Just give free up a bit more space. So this laptop 1.2 should be able to ping its default gateway, which is 1.1. So go to desktops, ping 192.168.1.1. Okay, getting a response. That's good. So we know then, can we ping 2.1? Ping 192.168.2.1. Okay, this seems to be a bit. Okay, so this is timing out. Okay, now that doesn't mean that the problem with the laptop, it could mean the problem with the router. But let's just sort of have a look to see what could go wrong with the laptop. Okay, and we can go into the IP config, the laptop. See anything in here?
Default gateway.
Missing a default gateway. That's the reason why we're able to ping 192.168.1.1 without a default gateway. The simple reason being is that 192.168.1.2, the laptop is on the same network as 1.1. That's not an issue. But we weren't able to ping 2.1 because we didn't have a default gateway set up on our laptop. Okay, so a default gateway means 1.2 will be able to ping 1. So no default gateway means 1.2 will be able to ping 1.1. Both of them are on the same network. However, 1.2 will not be able to ping any other device outside its network if it doesn't have a default gateway. Okay, so go in to IP config, put in your default gateway, 192.168.1.1. Yeah. Okay. Okay, see if can we ping 2.1 now. Ping 192.168.2.1. No, but we're getting a message back saying destination host unreachable. Okay, so we need to go into our router. Now that's strange because destination host unreachable, the router should be able to see that 2.1 is there because it should be in his routing table, unless there is an issue with the interface. Does that make sense? Anytime at all here, guys, if you're struggling to understand something, let me know. Let me show you. Let me go into the router here. The router with the CLI, enable, show IP int brief. Really useful troubleshooting command because it shows me directly a summary of the health of the interfaces. And you can see here gig 0/0 is opened up, gig 0/1 is up and down. That tells us there's an issue here with here. Now, it mightn't be Dublin. Chances are it's not Dublin. Why? Because the physical status in Dublin is up. So I would say that the issue here is on the Cork end, 2.2. Now the reason, does that make sense?
Yeah, that's all good.
So the reason why then, when that IP address is there in Dublin, why did it come back with saying destination host unreachable? Why did I get a response from the router to say destination host unreachable when 2.1 is up on the Dublin end?
Because it's not connected on the far side.
It's not connected on the far side, and it's down, and layer 2 is down. So in order for a route to appear in the routing table, the physical status, the layer 1 status must be up. The layer 2 status must also be up. So if I do a show IP route, that is not going to appear in the routing table. The network 192.168.2.0 is not in the routing table because the link is still seen as down. Yeah. If the road was blocked, you know, if the road was blocked, Google Maps shouldn't be pointing you to a road that's blocked because you can't use it. It should be pointing you to an alternative path. Now, at the moment, there's no way of getting to 2 dot across the network because, so in other words, the road, this is a routing table for Dublin. The 2.0 network is not there because the 2.0 network is down. And it's not to do with Dublin, it's to do with the other end, which is Cork. Again, just do a show IP int brief. And that looks okay. So we need to go into Cork. Into CLI, enable show IP int brief. Okay, and you can see here 192.168.2.2 and it's administratively down. Okay, so what we need to do is we need to bring it back up. So config space t int gig 0/1 no shutdown. That's up there. Okay, so we've got 1.2 is up, 1.1 is up, 2.1 is up, and 2.2. So how far can we get now? 2.1 is working. Can we get 2.2? Can we get 2.2?
Can't.
Why not?
No static route in place in the router.
Yes, yes, very good. Let me just... So what's happening is the ping is going across this 1.2 is going over to Cork. It's going into Cork on 2.2, but Cork is now unable to respond back to the 1.0 network because it doesn't have a route. So IP route. There's no static route in there. We've got our connected networks. We've got the local IP address that we assign to the interface, but we don't have a static route. So what about Dublin? Do we have a static route in Dublin? So IP route, no. So we need to tell Dublin about the 3.0 network. And we need to tell Cork about the 1.0 network. This is what we're kind of touching off last week. Okay, so let's tell Dublin about the 3.0 network. Big space T. Hey Dublin, IP route 192.168.3.0.255.255.255.0. So it's like, hey Dublin, in order to get to this network here, you can specify the next hop IP address. So this is the, this is the world according to Dublin here. So Dublin's next hop IP address is 2.2 space 192.168.2.2. And that kind of just reads, in order to get to this network here with this corresponding subnet mask, I need to go via 2.2 through 2.2. So anybody that knows Dublin, you'd be like, if you're in the city centre and you might see a bus for the 39 bus, which would bring you to Blanchardstown, and it might say via Navan Road or via Cabber. So in order to get from Dublin City to Blanchardstown, you need to go through Cabber. In order to get from Dublin to 3.0, you need to go via 2.2. That's what's saying there. All right. So we have to do the other end in Cork. So config. So yeah, if I actually, before let me just stop there for a second. There's two ways of doing a static route. There's that way there, just put it in the route and put in the next hop IP address. And the other one is to specify the local physical interface. So on the Cork router, Cork's local physical interface 2.2 is gig 0/1. So I'm going to configure a static route to get to 1.0, send it out gig 0/1. Is there any questions on that?
No.
Okay, config space T, IP route, hey, Cork, in order to get to 192.168.1.0, so with subnet mask 255.255.255.0, go via gig 0/1. You go out gig 0/1. And you just get this, when you do the interface, you get this message here. Default route. I personally prefer putting in the IP address 192.168.1.0, 255.255.255.0. Next top IP address 192.168.2.1. I prefer it. Okay, 255, yeah, that's it. All right. So I think we've got Dublin done, 1.2, 1.1, 2.1, 2.2. Is everything okay in Cork? Well, let's see if we can ping across. Don't follow the path again. Start in Dublin. Can we ping 2.2? Ah, we're getting a response now. We're getting a reply from 2.2 because now Cork knows about the 1.0 network. Knows about the 1.0 network because we told us so. Okay. Okay, so the next step is to ping 3.1. Ah. Okay, we're getting a message from Cork.
No gateway.
Destination host unreachable. But 1.2 has a default gateway. So why can't we ping 3.1? Let's go into Cork here.
Unless the port is down.
Okay, so we'll type in show IP int brief. Physical port is up, isn't it? Layer 1, layer 2. Anything that okay or? Anyone? Why can't we ping 192.168.3.1?
Oh, 198.163.
That's it. I tell you, and it's those they're the getches, they're the gotchas. When it has an IP address like that, it's so easy to, but it's one digit. Yeah, it's very easy to fall for. It really is. So yeah, so yeah, we need to change that IP to 192.168.3.1. The reason why 1.2 wasn't able to ping 192.168.3.1 is because 192.168.3.1 doesn't exist. So interface gig 0/0 IP address 192.168.3.1 255.255.255.0. I don't need to do no shutdown because the link was up anyway. So IP int brief. There we go. That looks a lot better. Show IP route. And now we can see the routing table. It has a static route. It has a connected route. So it knows it 1.0, 2.0, and 3.0. Okay, let's go back again. Can we ping 3.1? Yes. Okay, can we ping 3.2? Ah, we're good to go. That was it. 1.2 should be able to ping 3.2. Okay. The last thing we said is that we should be able to have this a loopback address or link to the internet. So let's go in here to Dublin. If we go back, exit, I'm going to do a show IP route. You can see this gateway of last resort is not set. So this means that if a router, or if Dublin, we're on the Dublin router, receives a route that is not in its routing table, it's just going to drop the packet by default. So what we need to do is create a loopback address, which is just our pretend link to the internet. And then we need to create a default route that says all unknown routes, send it across to 1.1.1.1. So config space T, interface, loopback, just give it a number, 0. Loopbacks are always up because they're a logical address. Interface loopback 0, IP address 1.1.1.1. And because a loopback is one software address, it can be a /32. So you can say 255.255.255.255. Exit, show IP in brief, and then we have a loopback 1.1.1.1, which is, if this is the real internet, you'd send, or you'd create a default route to send all your unknown packets out to the internet. Okay, so config space T, IP route 0000 space 0000 space loopback 0. So hey Dublin, all unknown routes, send it across to loopback 0. Now you have a default route. Okay. Dublin has a default route, but what about Cork? Can Cork ping 1.1.1.1? Let's check it out. Ping 1.1.1.1. No. Why not? Well, you're getting a response from Cork's default gateway to say destination host unreachable. So the Cork router is saying, I can't reach 1.1.1.1. Why not? Let's look at Cork. There you see it. Cork can't reach it because it doesn't know about the 1.1.1.1 address, and it doesn't have a route to it, and it doesn't have a gateway of last resort. So if the Cork router receives a packet going to 1.1.1.1, it's going to drop that packet by default because it doesn't have a gateway of last resort. So I need to configure a gateway of last resort in Cork to point to 2.1. So config space T, IP route 0000 space 0000 space 192.168.2.1. Does that make sense? All unknown routes with corresponding subnet masks, send it across to 2.1. And let's ping 1.1.1.1 now. 1, 2, 3, 4. There we have it. All right, guys. Any questions on that? Anything at all there? I think there is the answers are there in static routing. There is a folder there, static routing homework, and the answers are all in there, and they're obviously on that video there. Okay, so that's okay, yeah.
Yes,
Yeah.
thanks.
All right, cool, right. Let's close out of that. Right, you can't. Okay. Just give me a second here, one moment. Where are we here? All right. So here we have 4 devices connected to a switch. Okay, A, B, C, and D. PC A, B, C, and D. So say A, B, C, and D. A, B, C, and D. Yeah. And your devices that are connected into a switch are set to be one broadcast domain by default. So what's the definition of a broadcast domain? So I suppose the textbook, the CCNA or the CISCO textbook definition of a broadcast domain is an area in which devices can reach each other by sending a broadcast message. An area in which devices can reach each other by sending a broadcast message. If you think about it, a domain is an area. A broadcast is a broadcast area. So an area in which devices are able to reach each other by sending a broadcast message. Now, if this is layer 2, so all the switches destination MAC address are FFFFFFFF. So that's what a broadcast message is, yeah. So if we have a look here, what device is sending the broadcast message? Is it A, B, C, or D?
D.
It's D. No, it is D. Because a broadcast message is always from one device to everyone else. So it's coming from D. If you look at the direction of the arrow, it's coming in to the switch. The switch obviously is looking at the destination address on the frame. Is seeing that it's all F, so it's saying, oh, they're going to all Fs. So the fact that it has all Fs means that it's going to go to everywhere. We're going to send it to all active ports. So when a switch receives a broadcast message, it will send the frame out all ports except the frame on which it came in from, which is the port that D is connected to. So let's say if this was port 4, for example. So it would send it out port 1, port 2, port 3, but not port 4 because it came in on port 4 in the first place. Switch would never send a broadcast message back out to 4 when it came in. Why would it do that? Why would it send the message out of port that the frame came in the port in the first place? Okay, so a broadcast domain is an area in which devices can reach each other by sending a broadcast message. A more common known name for a broadcast domain is broadcast domain is a broadcast domain is a network. A network is a broadcast domain. A broadcast domain is a network. They mean the exact same thing. They're interchangeable because devices will send a broadcast message. A broadcast message only goes to the same devices in that network. It won't, a broadcast message will not go across, will not be transferred over to another network. So broadcast domain is a network is a broadcast domain. Okay, so here our example is we've got 4 devices connected into a switch, 1 broadcast domain. Fine. That's not going to be, switch takes this broadcast message and sends out 3 ports. Okay. But let's say we got a larger switch here. Many broadcast domains by default here. On this CISCO, it's a little bit old now, CISCO 4500 switch. Jesus, those, yeah, you'd never see the line cards being copper. Usually those line cards will always be fiber, SFPs and QSFPs. How many networks on this switch here? By default? One. Yeah. One. So you've got 5 line cards. These are line cards. Let's count. One, 2, 3, 4, 5. You could even, yeah. And these guys here are probably your uplinks. They're fiber. But let's just concentrate on the line cards. You've got 5 line cards. Each line card you can see clearly has 48 ports. 5 multiplied by 48 is 240. 240 ports there. Okay, 240 copper ports where you could have PC connected into copper interfaces, and you could have 240 of those PCs. That means if this is fully populated, then generally this wouldn't go. You wouldn't have your PC directly connected into a 45 into the switch. The PC would go to, you'd have a patch panel. So you'd have something like this, another rack here beside it. And you'd have a patch panel here. And you'd have 2, 3, 4, 5, and just, yeah. And then you'd have it connected in here. So you connect the PCs to the patch panel, and then the patch panel will connect it to the line cards. Anyway, so 240 ports. So this means if you have a PC connected in here, and this PC sends a broadcast message, who's it going to go to?
Everyone.
Everyone. The switch will send it out all ports, because a broadcast message by definition will go to all devices within the same network. And by default, all those devices are on the same network. So that's only one PC. Now you could say, oh, it was one PC sending a broadcast messages, but PCs are constantly sending broadcast messages, especially more modern day devices that are connected up to the internet. Everything you do is online. You know, even if you open up Microsoft Office, it's Office 365 as online. You know, you make changes, everything's gone up to the cloud. So there's broadcast messages to help all the applications. Our applications love using broadcast messages. They're not very efficient, but the application doesn't mind, because it's not that, you know, it's the network that's going to be hammered. So, and this is one PC. So this one PC is sending out a broadcast message, and it'll be sending out a broadcast message every second or so. That's going into 239 devices. But the other 239 devices are also sending broadcast messages. So there'll be a constant stream of broadcast message going around and around and around and around. So it's not a very way, it's not a way of optimizing your network, having these 240 devices within the same flat network segment. Okay. Let's say if you're in a data center, okay, and you're in AWS or Amazon, move this across. And Amazon's data center, let's not even say Amazon. Let's say you're hosting, your company are hosting, you're a data center, and you're getting paid. You're managing this data center where you've got a number of different companies. Okay, so let's say we have companies. Let's say we have AIB. Which is red. Let's say we have IBM, which is black. And let's say we have the ESB. I'm just using all nice. Yeah. So basically, these are 3 companies, and they are paying your data center to host some of their servers for whatever reason, right? Now, inside the rack, their servers are connected to a switch like this. AIB might have 48 servers that will connect in to this line card here. So this is AIB's. Oh, God, let me just use the red here. IBM would have 48 servers connected in here. Right. It's very hard to see that. Let me say IBM is here. And ESB is the next one here. So these are all connected into racks, and each rack can host, let's say, 48 1U servers. Any questions on that? But the problem is that AIB and IBM and ESB are all three different companies. And if this was a flat network, which what it is by default, it means that if we have a server that is connected to a rack, an AIB, or let's say we've got a server here, and that server generates a broadcast message, that's going to go to every one of these devices. It's going to go to the IBM servers, it's going to go to ESB servers. They're all going to receive that broadcast message because he said this is one flat domain, this is one flat network. So what you can do and what we need to do in a situation like this, well, there's two things we could do. What's our sort of legacy way of separating networks? Use a router. Yeah. And a router, every interface is a member of a separate network. So we could buy a switch here, okay? And this could be our AIB network. And we could buy another switch here, and this could be our ESB network. And we could buy another switch here, and this could be our IBM network. And that would work, yeah. Because if IBM generates a broadcast message, it's only going to go as far as this network here, this interface, and the router's not going to send it on because routers don't forward on packets, okay? But these are three companies in a data center. A data center could have 50 companies that it's managing. We're going to have to buy 50 routers? Each company has its own router. No, you don't need to. Well, first of all, it's very, very expensive to do that, and you don't need to do that. What you can do is take this switch and you can segment it, you can divide it or break it. And I don't mean break it as in physically break it. I mean, you can divide it into multiple different networks, multiple different broadcast domains, multiple different VLANs. See, the three terms that we're talking about are interchangeable. A network is a broadcast domain, is a VLAN. A VLAN is a network, is a broadcast domain. Okay, so if we come back here to our switch again, let me just kind of remove some of the, let me see if we can do this. Oh. See if I can get rid of that circle. Oh, there we go. Okay, what you can do here is you can create three different VLANs. You can create a VLAN for AIB. And have all those ports on the AIB network, on the AIB VLAN. You can have a VLAN for IBM. And all those ports would be connected to the IBM, all those servers. So you have these are NIC ports, all these servers, all the IBM servers are the IBM cabinet, which is here somewhere, will be connected to that server here. The AIB server, AIB cabinet, all the servers will be connected in there. The ESB one again, you have an ESB VLAN here. And what you've done then is if a server in the AIB VLAN generates a broadcast message, oh, wrong color. Who gets it? Only the AIB servers, only the AIB hosts. The IBM one don't get it, the ESB ones don't get it, no one else. Let's say ESB move off. They finish their contract after a year or so. Yeah. And they take all their servers out of that rack. This is your data center. And AIB see that that rack is now free. You tell them that there's another rack there free, you can house your servers. And AIB go, oh, great. That rack that was occupied previously by AIB, well, that's AIB want it, or by the ESB, AIB want it. So you can take that AIB come in and now create a VLAN. And this VLAN here could, or it doesn't have to be, in the same VLAN as these guys. These two racks can talk to each other through the switch. Their information is going to be kept separate from IBM and vice versa. So that's another reason, that's the main reason for VLANs, for security, for creating different networks at the layer 2. It's a layer 2 feature. This is a layer, I'm not talking, this is a layer 2 switch. Okay. Any questions on that? I'm trying to sell these VLANs today. I'm a VLAN salesman. Another company comes in. See, this is the thing, you don't need to buy extra routers. All of your all of your network segments can be done on the switch here. So this switch here, you could house 5 racks. 1, 2, 3, 4, 5. And each rack would be belonging to a different company.
Sorry, Lee. Is
Yeah.
there a significance to the color on the markings on the right-hand side to the network ports? So I see there's like a pink, a purple, a red, blue, pink.
No.
So there's not a repetition there for a reason, no.
No. I think that's just by design. No. There's nothing. There's no technical reason.
Cool.
It's a good question, but yeah. There might be. I haven't heard of it, but yeah, no, it shouldn't be. Well, you can see all here up to here. You got your power supplies as well. So you got. This would be typically going into a server rack. You got multiple powers. You've got multiple power supplies. Each one you'd have an A buzz bar and a B supply. And if one of these, if the A breaks, well, you still got power going to the B. And if one of the power supplies units fails, the other one will kick in. So we got redundancy there. Okay. Another reason, let's go just talk about another reason why we have VLANs. Let me open this document again, Paint. Let's say this is Google's switch, right? And there are ports in an office. So all of this switch is in the comms room, Google or whatever, and they've got each line card belongs to a corresponding floor. Okay, so you got your first floor here. You got your second floor, you got your third floor, you got your fourth floor, and you got your fifth floor. And they're all rooms. So you got a room on the fifth floor and all the ports here, room on the fourth, room on the third, room on the second, room on the fourth. Now, let's say the first floor is the lobby, or it should be the ground or whatever. And you have, typically this is your public, it's open to the public. If public want to go in and see how great Google is as a company, they're connected in here. Yeah. And on the 5th floor, Google are doing a lot of research and development, and they're researching the latest Android phone or Google phone or whatever, right? Now, again, by default, these devices are all on the same network, right? But you have a user, Mr. X, who's a hacker, who manages to connect in to one of the floor ports on the lobby. It's open, not shut down, and he's got an Ethernet cable, and he connects in, and he's getting an IP address from DHCP, let's say 192.168. This is a terrible way to do things. Google would not have this, by the way. 192.168.1.8, far more secure. And all of a sudden there, he's able to send information and receive information from the devices upstairs in this research and development, because it's all the same flat network. So there's a massive security risk there. So what you could do is, again, you'd have different networks because you have different functions. These floor ports are all different functions. Some of them are connected where the public can use them. Other ones are for more research and development. So maybe you should have a public VLAN down here. And you could have specific access on this public VLAN. Anybody that connects into this public VLAN, where are they going to go? They're only going to go to the internet. They're only going to have basic internet access. Where this guy here is going to be on a completely different network. The servers, the hosts, the PCs in the research and development are going to be on a different network, so that if somebody connects into the public here, public lobby, although they're on the same physical device, they're all on the same physical switch, they're logically kept separate by each other by using VLANs. All right. Any questions on that? Okay. All right. So let's show you how to. Now I'm just going to show you on Packet Tracer how to do this. And to create VLANs. Now, tomorrow we'll do a lab, so don't worry about doing any labs here today, because I want to go through this quickly. And we'll do labs tomorrow. We'll do some sort of lab tomorrow, hopefully. Oh. All right, let me just make this bigger. Tools, we just grab. Okay. Copy. Right. So let's say we have, I'll paste this in here. We got two devices. We got, let's say this is a company switch, and we got HR. And we got sales. And we want to keep, or no, this is no, actually, another would be even better. We have, it's a university switch, and we have the staff, teachers, secretaries, administration staff, lecturers, and then we got the students. So some of the floor ports in the classrooms, the students can access, and then we've got some of the floor ports or some of the offices in the staff, but they're all connected back to the one physical switch. But the problem is, if we didn't have this being one network, some enterprise and students would be able to set up. There's lots of hacking devices. Like years ago, to be a hacker nowadays, you don't need to have advanced Linux knowledge. You can just download scripts and programs and hack on your, and connect in your Windows 10 and PC and open up YouTube and get lots of stuff on it. Like it's not like years ago where you have your stereotypical hacker like Jurassic Park with a cigarette hanging out of his mouth and typing this geek. Those days are gone. So your students could use a program like Cain and Abel or something like that and find out, trying to connect into the staff or do a man in the middle attack and maybe just, I don't know, cause problems. So what we need to do is we need to separate the staff ports, floor ports for the staff and the floor ports for the students. So let's say host number 2 and host number 4, these floor ports, I'm going to put red. Okay, these are floor ports on the switch, and host number 3 and number 1 are going to be blue for the students. Now, another thing that I'm putting this in just to show you. You can see here that the 4 PCs by default are using the same, they're in the same network range. They're using the same layer 3 subnet, 172.34.34, okay? If you are creating VLANs, you would never have them in the same layer 3 subnet. If you're separating them at layer 2, you would have a different layer 3 subnet, okay? What I mean by that is, so let's say we're going to create VLAN 2, or let's say VLAN 3 for the students, okay? You would give them a subnet like 192.168.3.0. If we're going to create VLAN 2 for the staff, then you give them a subnet like 192.168.2.0. Good idea to have the third octet matching the VLAN ID. You don't have to do that, but it just makes sense, okay? You're separating them in layer 2. You're also putting them in different layer 3 subnets because they're going to be separated anyway. You need to do that. But what I'm doing in this example, we're not going to be doing that. I'm in this example here, I'm all having them in the same layer 3 subnet because I want you to show the difference, what a VLAN does. Okay, so these are your devices. Again, these two here are going to be in. Okay, so host 2 and host 4 103. Okay, so let me just go into my switch. Right then, let's see if we can have. Okay. So enable show VLAN, and you can see show VLAN command tells you you've only got one VLAN on your switch, which is VLAN 1. Only got one VLAN on your switch, which is VLAN 1. You've only got one network on your switch. We said that we got VLAN. We said that you've got one broadcast domain by default. You've got one VLAN by default, and that VLAN ID is VLAN 1. And if you have a look, all the ports that are on this switch are members with VLAN 1. They're members of VLAN 1. So again, if you have a device connected to FA0/12, and this device generates a broadcast message, it will go to all of these devices in the same VLAN. Is that okay? these guys here are only there for legacy compliance things. They don't do anything. FIDI and token ring, they're really, really older. Jesus, 30 years old at this stage. Okay. So this is one VLAN, one network, and all those ports are associated with that one VLAN. So what we want to do is we're going to create 2 extra VLANs, VLAN 2 and VLAN 3. Okay, very simple. To do it, it's a global config command, config mode, VLAN space 2 and enter. I've just created a VLAN. So switch is switch by VLAN ID, which is the number here. You don't even need to put a name in. Switch is switch by VLAN ID, by VLAN number. If you want to put a name in, it's only really for the human's sake. It's only for humans to see the function of the switch, so that, or the function of the VLAN. So in this case, our VLAN is going to be, VLAN 2 is going to be for this, what do we call it, students. So we say name students. So that if someone else is logging into the switch and he says show VLAN and says name students for VLAN 2, I'll go, oh, okay, this is the students port. Exit. VLAN space 3, namespace staff. Exit. That's it. Created 2 VLANs. Exit. Show VLAN 3. So how many broadcast domains do we have now?
3.
Yes and no, kind of. Because is it really a broadcast domain if you don't have any active ports?
And there's only one currently set up.
Only really one. So yeah, you can create as many VLANs by default, but they're not going to be active unless you actually put ports into those VLANs. So the next step, excuse me, sorry, just drink water. I'm talking after a while, it just you get dry throat. The next step then is to take the ports out of VLAN 1 and put them in the respective VLANs. Okay, so host 1 and host 3 are going to be in the students VLAN, host 2 and host 4 are going to be in the staff VLAN. So what will happen is when you take a port out and put it into another VLAN, it's going to leave VLAN 1. So FA0/1 is going to leave VLAN 1 and go into VLAN 2. You can't have FA0/1 in VLAN 1 and in VLAN 2 at the same time. A physical port cannot be a member of 2 VLANs. Okay, so now to do that, you need to go into the port level. Space T, because I am taking FA0/1, which is the port on the switch, and I'm putting FA0/1 into the students VLAN. So I need to do that on int FA0/1, enter. Config-if. Anything I type in here is going to affect interface FA0/1. So I'm going to say, okay, so let me just stop there for a second. I wanted to do another talk just briefly. So these ports are called access ports. I did briefly talk about this before. Access ports. Okay, an access port is a connection to a single host, such as PC, printer, server. Typically, there'll only be one MAC address associated with it. Sometimes called an end device. Okay, that's what an access port is. So an access port on a switch, and this is where we're using the term access port, a switch access port is a connection to a single host. So we've got these 4 ports here, yeah? Port number 1 is an access port. Number 3 is an access port. Number 2 is an access port, and number 4 is an access port. Okay, why? Port number 1 is an access port because the device connected to it is a single host. So one device. There's only one MAC address associated with port 1 at any one. Let's say this MAC address is AAA. The switch will say the device connected to me on port 1 that has a MAC address of AAA. Now, if I remove it, if I do this, if I take out AAA and give it a different PC, BBB, and I connect in port 1. So I remove this guy and connect in here. Well, then BBB is going to be associated with port 1 because it's only got one MAC address associated with it, and that happens to be the MAC address of the device that is connected to that port at that specific time. It's seen as an end device, because any packets that leave the switch on port 1 terminate here. They can't go anywhere else. Goes into the NIC card and that's it. It's like a cul-de-sac in a road. Okay, it's going to end. Does that make sense? You're not going to go off anywhere else. This NIC has only got one connection. It's not going to go off to another switch, which is going to go off to the internet or somewhere like that. Okay, it's all, so any local traffic is only going to go across here. Where did we see this before? Setting up access ports. It was week 2, I think, that we looked at this. Or week 3 even. Setting up port security. In order to set up port security, we had to configure the port as an access port. So that meant that you can't set up port security on an access port, because let's say here, what happens if the switch port brings down this port? Who's affected? One device, because you've only got one device connected to an access port. Now you're probably saying, well, if that's an access port, what's the alternative? Obviously, there has to be another type of port other than an access port, and that is a
Trunk.
Trunk. Some of this. Circle down. There we go. Okay, so switch access port connection to a single host, PC, a printer, or server. So we got one MAC address associated to an end device. So the alternative to that is, get rid of this, bring in a router. Or actually what I'll do is I'll bring in a switch, keep it simple. Switch to switch or switch to router. And this port here is a trunk. So trunk ports are switch connections, multiple MAC addresses, are going across the switch port. I'm going to keep that. I'll show you later on in an example what I mean by multiple MAC addresses are associated with a switch port. With a trunk port, sorry. Multiple MAC addresses going across it, switch to switch connections. If a trunk link goes offline more than one device will be affected. Right, what do I mean? Well, let's say here we've got switch to switch. So this is switch A, and we've got switch B, and we've got PCs over here. We've got PCs over here, and then we've got a connection to the internet is here for some reason, and we got a router here. So if this trunk port goes down, well, devices on host A will not be able to speak to devices on host B, and they will not be able to go into the internet. Whereas if a device, if an access port goes down, who's affected? Only one device. If a trunk link goes down, who's affected? 50, 100, multiple users will always be affected because it's a switch to switch connection. So any questions on the differences between a trunk port and an access port?
Did you set up a VLAN for a trunk port as well as an access port?
That's on the way. There's a difference when it comes to the VLANs. It's a great question. And when it comes to VLANs, they handle traffic differently with an access port than they do with a trunk port. So that's why I wanted to get over the concepts of understanding a trunk port first versus an access port. So once we've that kind of drilled into is, then we'll look at the function of an access port versus the function of a trunk port, and how the switches deal with traffic belonging to an access port versus a trunk port. Okay, so let's close that there. Just open the paint again now. Cool. Let me make this a little smaller. Oh no, let me just paste. Okay, so what we were doing, I wanted to just clean this up a bit. We were there. So these are all, so if you just, let's give port numbers here associated with them. So this is host number 1, host number 3, host number 2, and host number 4. Okay, and the ports on this port 1, 2, 3, and 4 on the switch. All right. So port number 1 and 3 are meant to be the student staff. Was it? Yeah. Oh, okay. So 1 and 3. Sure, this is right. So these two are going to be staff, and 2 and 4 are going to be the students. Now, before we do that, we know if I do show VLAN, even though we've created the extra VLANs, they're all on the same network. They're all on VLAN 1. So they should be able to ping each other. So 34.34.2. Let's ping in 172.34.34.3. Ping in 172.34.34.4. Ping. Yeah. So they're all pinging. Okay. So host number 1, host number 3 are going to be students. Host number 2 and host number 4 are going to be staff. So config space T. Trying to fit this in. Yeah, I'll just configure host 1 and 3 first. So interface FA0/1. Switch port, mode, access. What I'm doing is I'm saying to the switch, hey switch, the device connected to you on FA0/1 is an access device, which is host number 1. So host number 1 is physically connected to interface FA0/1. That's all I'm doing, switch port mode access. The next command is where I take FA0/1 that is in VLAN 1 and I associate it with the staff, which is VLAN 3. Okay, switch port access VLAN 3. You can see it changes. Okay, so I've taken FA0/1, which was a member of VLAN 1, and now FA0/1 is a member of VLAN 3. Okay, I'm going to exit out. Interface FA0/3. Switch port mode access. Switch port access VLAN 3. So now FA0/3 is going to be a member of VLAN 3. So 1 and 3 are on VLAN 3. And then 2 and 4 are going to be in VLAN 2. So exit out of there. Interface FA0/2. Switch port. Now there's, yeah, that's the long way. Switch port mode access is saying to the switch, hey switch, this is an access port. This is an access port associated with VLAN 3. There's another way you can do it even quicker. Switch port access VLAN 2. And that kind of just covers those two commands in one go. Interface FA0/2. This is an access port associated with VLAN 2. Does that make sense, guys?
Yep.
Okay, exit.
Yep.
FA0/4. Switch port access VLAN 2. Because 2 and host 4, host 2 and host 4 are on VLAN 2. Host 1 and host 3 are on VLAN 3. You can check it out and show VLAN. Always do show VLAN. Always make sure that you're, you know, even every step you make, you should verify, because you don't want to make 30 changes to the switch and then have to test. Because if you make 30 changes to a switch and you're testing something doesn't go right, how are you able to troubleshoot where the issue is? So every change you should make, you should test after it, straight away after it. That means because you're laying then, you're testing each change, and if a change doesn't go right, then you just go back to the previous change. Okay. So now, yeah, now we have 3 broadcast domains. VLAN 1, and the most of the ports are associated with VLAN 1. VLAN 2 and FA0/2 and FA0/4 are in VLAN 2, and VLAN 3, FA0/1 and FA0/3 are in VLAN 3. So earlier on, this is why I wanted to put all the devices in the same layer 3 subnet, because I wanted to show you the differences before and after VLANs. And the only way I could accurately demonstrate it to you was if I have them in the same layer 3 subnet. So host 1 is only going to be able to communicate with host 3. Earlier on, host 1 was able to talk to host 2, host 3, and host 4. Let's try and ping 2 now. See, even though they're in the same switch, and even though I have them in the same subnet, host 1 will not be able to talk to host 2 because they're in different subnets. Sorry, they're in different VLANs. We'll be able to talk to host 3, but not host 4. So 1 and 3 will be able to talk to each other. 2 and 4 will be able to talk to each other. ping 172.34.34.4. There's VLANs. Okay, any questions on that?
Well, you were just saying it's best practice to have them on different subnets. Is that
Yes.
purely just so it's easier to manage them,
No.
or is it just practice?
No, you have to have them. You have, like, it's not even, sorry, I kind of missed my words there. Not only is it best practice, it's the only way you can do it. You can't have them on, it's really bad design. If they were on the same layer 3 subnet, it wouldn't make sense. And you'll see why when we start looking at going into different networks. We start looking at router on a stick and stuff like that. You have to have they're separated at layer 2. You have to keep that separation going across layer 3. You just have to. It wouldn't work otherwise. Okay. So is that there? Actually. No, right. Okay. Okay. Go back to my slides here for a sec. So the definition of a VLAN, and we looked at broadcast domains. Here's a picture here. I'll look at paint. You remember what a collision domain was? So the collision domain was every port on a switch is a separate collision domain. So if we look at this diagram here, how many broadcast domains do we have here? How many collision domains do we have? Now, by the way, this old device here is a hub. So this is a hub. Tell you straight away, how many collision domains you have at a hub? Only one. So how many? Let's have a look at the collision domains. So we got one here, we got two here, 3, 4 collision domains, 5, 6, 7, and 8. So you got 8 collision domains. Eight areas where the device can send and receive information at the same time without having a collision. How many broadcast domains do we have?
3.
Yes, very good, very good. So how many? Another way of saying how many broadcast. If you got a question to ask you how many broadcast domains, just say to yourself, how many networks do we have? We got 3 networks. 3 networks. Network number 1. Network number 2. And network number 3. By default. 1, 2, and 3. 3 networks. Okay. So just to cut across again, there's a lot of theory here talking about VLANs. So VLANs give us the ability to logically group users by whatever function we want. So we've looked at the different examples there already. So earlier on, we said that we had a 4500 switch in a data center, and the data center was grouped by companies. We had IBM was one VLAN, we had AIB was another, we had EBS or ESB was another VLAN. So they were logically grouping users by their company. Or we could be the same company or the same college, and we would have a staff VLAN. or a student's VLAN. It's logically, you can group it whatever way you want it to do, whatever, depending on your business requirements at that time. VLANs give us the ability to create extra broadcast domains, which makes our networks more manageable. Again, I'm going to go back here to this switch. So earlier on, we said by default, we had if one PC generates a broadcast message, it goes to 239 PCs. Yeah, because these 240 ports are in the same VLAN by default. Yeah. So let's say what we'll do is we'll create 10 VLANs on this switch. Yeah. So 10 VLANs, and each VLAN has 24 ports. Okay, 10 VLANs, each VLAN has 24 ports, right? So let's say what you have here is bit darker. VLAN 1, VLAN 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and if you have a host on VLAN 1, generates a broadcast message, who goes to it? So this PC on VLAN 1 generates a broadcast message.
23 users.
23 ports, yeah. 23 users will get it. Much more efficient. You're actually giving yourself extra broadcast domains, but each extra broadcast domain will be smaller and more manageable. You're not giving yourself extra bandwidth. The bandwidth will still be the same. It could be, you know, gigabit ports or 10 gigabit ports. But what you're doing is you're saying that you're optimizing the bandwidth that you have there in place. Okay. Does that make sense?
Yep.
So it gives you the ability to have extra broadcast domains, extra networks, because we created 10 VLANs, 10 networks from there. And your subnet correlation should match as well. Very important, your subnet correlation should match. So what we'd have is VLAN 2. And again, you should really do, if you got, let's say you got red VLAN, VLAN 3, which is red, have that subnet 192.168.3.0. VLAN 4, which is blue, 192 blue, sorry, VLAN 4, blue VLANs 192.168.4.0. You have to match, you have your subnet correlation should match your VLANs. The third octet in your subnet should match. Now that doesn't, that's best practice. Okay, it doesn't have to be that way. If you wanted to be really awkward, you could do something like VLAN 14 and then 192.168.4.0. But that's just confusing. You know, you really, it should, you know, if you look at a subnet, you should be able to see, oh, okay, that's VLAN 3 or that's VLAN 8 or VLAN 5 or whatever, based on the third octet or where the up here. All right. Okay. So let's say, for example, we have, get rid of this. switch A, switch B. There's two switches. Because switch A, switch B, yeah. I'll have to continue this after. And we have two VLANs. So we got our black VLAN, which is VLAN 2. I like using colors because much easier to explain things. And you got a red VLAN, which is VLAN 3. Okay, now across these two switches, you got devices in switch A and switch B. Okay. So you've got PC here, PC here, PC here, PC here. So we got 3 black PCs on A, 3 black PCs on B, and then red PCs, red PC here, red PC here, and a red PC here. The same over here. Okay, so what we'll do the ports. So your physical ports. So this is going to be port number one, number 2, number 3, number 4, number 5, and number 6. And this is going to be port number 1, 2, 3, 4, 5. And let's say the trunk ports connecting A to B is port 9 here and port 9 here. Okay. So what we'll do is there's no point in going in further into this because this is a little bit confusing and we'll have this as half. So what we'll do is we'll take 15 minutes and then we'll come back and we'll explore this in more in depth. Okay, guys?
Cheers.
Okay, so see you as a quarter, yeah? Sorry, but I was actually trying to set up this thing on GNS3 to use multi-layer switch. I'll talk about later on. Okay, so we're back here. I wanted to show you how it works. So we got switch A and we got switch B, and we have 2 VLANs set up. Yeah, we have the black VLAN and the ports associated with the black VLAN on switch A is 3, 4, and 5. Does that make sense? 3, 4, and 5. And the ports associated with VLAN 3 on switch A is 1, 2, and 6. So the ports associated with the red VLAN, which is VLAN 3, is ports 1. There's red here. 1, 2, and 6. Does that make sense? So let's look at the if we go back off here and I do a show VLAN. This is your VLAN database. And basically it has a VLAN ID and the ports beside it. VLAN 2. The name is only really just for cosmetic reasons. It's always a VLAN tag and the ports. So here, trying to get a little bit more space here. Yeah, okay. So switch A is going to have a VLAN database, okay? Switch A's Okay, so it'll have VLAN 2, VLAN 3. And then it'll have VLAN 2, it'll have the ports associated with VLAN 2 are 3, 4, and 5. Does that make sense? Port 3, 4, and 5. VLAN 3, the ports associated with it, ports 1, 2, and 6. Does everyone see that?
Yeah.
Yeah. Yep.
And then the trunk link is port 9. So I want to do the same thing over here on switch B's, VLAN database. Like the port on switch B don't have to match the port on switch A. They can be floor ports. They can be completely different. For example, port 1 is 1 and 5 are on VLAN 3 on B. So VLAN 2 is port 2, port 3, and port 4. VLAN 3, port 1, port 5. Okay, so let's say you have a guy, let's say port 4 here generates a broadcast message. Okay, PC on port 4, I'm just saying port 4 because I want to have a bit of space. So this PC on port 4 generates a broadcast message. Source MAC address is A. Destination MAC address is FFFFFFFF. Okay. What happens is this frame is going to go in. It's being generated by this PC here. So that PC, I'll put it in, maybe we'll put it in green so we can follow it. PC is going in to port 4, physical port 4 on switch A. Okay, switch A receives it and looks at the destination MAC address and says, oh, FFFFFFF, that's a broadcast message, but it's a broadcast message to only go to devices in the same VLAN as port 4. So it does like a cross reference. It looks at the MAC address, looks at the physical port that this frame has come in on, which is port 4, then checks that against its VLAN database and says port 4 is in VLAN 2. So therefore the other ports that this needs to go to is port 3 and 5. So switch A will send it out port 3 and send out port 5. It won't send it out port 1, 2, and 6 because port 4 is in a different VLAN than the ports in 1, 2, and 6. Does that make sense? Who else will get this broadcast message?
Well, switch B should also get it. Should.
Switch B, who on switch B should get it?
VLAN 2 on switch B.
The ports associated with VLAN 2 on switch B, which is ports 2, 3, and 4.
But the fact that you got two separate VLANs going through port 9 between both switches, is that a problem?
But they're not separate VLANs. They're the same
I know,
VLANs.
As in VLAN 2 and VLAN 3.
Oh, so okay, yeah, sorry, yeah. So, well, this is it, right? So,
It's going through as a trunking operation, is it?
well, so switch A says, okay, so switch A looks after its local switch port first. And it says, okay, all these devices have received it. Port 3 has received it, port 5 have received it. I'm done. But now there's a trunk link between A and B, okay? And basically trunk connections between A and B, they're best buddies because switches with trunk links are there's so much in common. So switch A says, I better send this over to my BFF, my best switch forever. But before I do that, how is switch B going to know this is a broadcast message? What's on switch B to tell switch B this frame here is a broadcast message? So this frame is going over, it'll go into switch B and port 9. Does that make sense? Well, how switch B knows it's a broadcast message, it's going to say FFFFFFF in the destination MAC address. Yeah. But how does switch B know it's a broadcast message to only go to VLAN 2?
It'll have to be told where it came from to know it's VLAN 2.
Exactly. Very good answer. So what will happen before switch A sends this frame across to switch B, it will put a tag. It will put a VLAN tag to tell its best friend that this is a frame, broadcast frame, to only go to devices in VLAN 2. It's a VLAN tag. Think of it as a little extra piece of information. It's like a sticky note. Sticky notes are great for limited information that you want to have. You know, if you want, maybe somebody stealing your milk in work in the fridge, you might put a sticky note, say this milk is mine. Or something like that to that effect. Okay, it's a little note just to tell other people that, yeah. So this frame here is a sticky note that A puts in it when it goes over the trunk link in order to tell B that this is for VLAN 2. Because otherwise B is not going to know. How is B going to know that this frame is only going to VLAN 2? It's not. So A has to tell it and puts on a VLAN tag. And this is an IEEE process called 802.1Q. IEEE 802.1Q. So it means you could have a Cisco switch here, and you could have like an Avaya switch here, and it'll just work. Now, Cisco have their own tagging called ISL, but it's gone. They don't use it anymore. Okay. 802.1Q is the industry standard. 802.1Q is basically this setup here. We got switch A, you got switch B, you got a number of ports, and before it sends it across, it has to tell it. Look, actually, you know what? Let me just show you in GNS. So I've set up GNS to run on a VMware machine. And because I'm setting it up to run on a VMware machine, I can incorporate a multi-layer switch. So we'll call it switch A here. What I will do is, one second, there's a lot of work in it. And what I can do is I will look for actually here, let me just 1 second. There's a very good YouTube video on how to install GNS, how to install GNS3 VMware with a Windows 10 machine. Okay, so I'll just put this into the chat. So 1 second, use this chat here. Okay, have a go at it there. That's installing it. So that's how to install GNS 3 VM 2.2 on Windows 10. Okay, and there's another one. Once you install it, then you need to get a layer 3 switch, a multi-layer switch. because GNS doesn't come with a multi-layer switch by default. Okay, there's a separate tutorial which is how to add a layer 2 multi-layer, a layer 2 or a multi-layer switch on GNS, and that's that one there. Use a VM, but do the first video first. So use the install GNS VM first, and then use the add multi-layer switch. Okay, have a go at that. What I might do is one of the weeks I might try and uninstall GNS and do the whole thing from scratch, depending on how you go. Okay, but okay, I got a switch A here. I got switch B. And you can see them both running off. They're not running off my actual desktop. They're running on my VM partition. So I want to connect into two of them together. So Ethernet, let's say 0/0 is my trunk. Okay. So 0/0 to 0/0. Connection. Okay. Okay, now what I want to get is a couple of PCs. I don't want to have, so what we'll have is we'll have 4 PCs, okay? So I get 2 PCs in VLAN 2 and 2 PCs in VLAN 3. So let's say PC here, VM, PC here. Sorry, delete that again. PC over here. Okay. PC1 and PC3. Actually, what I choose, let me change the symbol on this. Red, guys. I'll just put these in red. Where is it? Just a normal PC client. Oh, just here. Yeah. Get that client. There's PC1 and this and PC4. Okay, perfect. There we go. 1 and 4 are their clients, right? So they're going to be in VLAN 3. So red guys are in VLAN 3. Okay, and the blue guys down here are in VLAN 2. Okay, let me just add another PC in here, so we can just see what's happening. So PC, another one here, and he's also going to be blue. So connect up. I'll put on these 1/1, 1/2. 1/3. 1/1, 1/2. Okay, so let me just do a view. Show hide interface levels. Yeah, okay, so we can see what's connected into what. So our trunk links are what ports? Our trunk links are
0/0.
0/0. Yeah. Okay. So our 2 PCs on a red VLAN are going to be connected to 1/3 and on A,
And 1/2 on B.
on 1/2 on B. Now I want to keep it separate because because you know they will be different in a real world environment. You know, and that's the way it will be set up in a real world environment. It's not going to be 1/3 on A and 1/3 on B. They're not going to match. You don't need to match. Okay, so let me just turn on everything here. Start. Okay, this will take a few minutes to configure, but it's important because I want to show you the actual inside of the frame. I want to run Wireshark packet capture, and you can see the difference. You can see the VLAN tag, and we can talk about it then. Yeah. Okay, so let's see. PC1 is VLAN 3. Okay, so VLAN 3's network will do 192.168.3.0. VLAN 2's network is 192.168.2.0. Okay, so PC1 is going to be 3.1. PC4 is going to be 3.4. Okay, 3.1. 3.4. I'm going to have their PC IP address right beside them. Everything on the blue VLAN, which is PC3, 2, and 5. PC2 is going to be 2.2. PC3 is going to be 2.3. 2 because it's in VLAN 2. 3 because it's PC3. And PC5 is on VLAN 2. So it's going to be 2.5. Does that make sense? 2.5. 2.2 and 2.3. Okay, so I'm going to connect on. Actually, we have to start console into this PC here first. So IP space address 192.168 dot. .1 255. IP address 192.168. IP 192.168.3.1. Okay. PC2 is 2.2. Okay. PC3, PC4, and PC5. IP 192.168.2.2. PC2, yeah. VLAN 2 and it's number 2. PC3, IP 192.168.2.3. PC4 is going to be 3.4. PC4 is going to be 3.4 because it's a red VLAN in VLAN 3. Yeah, IP 192.168.3.4. PC5, IP 192.168.2.5. Okay, so after setting up the PCs, need to set up the 2 switches. Okay, so go in here, console A and console B. Tomorrow we will do a lab together on Packet Tracer with this. So don't worry about it. I just want to show you setting up trunk links, and I want to show you the inside of a VLAN tag by you running GNS, by running Wireshark, okay, and looking into how it works. Okay, so create our VLANs. Switch A, we're creating 2 VLANs. VLAN space 2, name space blue, VLAN space 3, name space red. Okay, same thing. Go into your VLANs, config mode, VLAN 2, name blue, VLAN 3, name red. Exit, exit, show VLAN. Yeah, so you can see they're active. Okay. So what I'm going to do now is associate 1/1 and 1/2 with the blue VLAN. Guys, anything you're stuck on, let me know. Okay, so config space T int ETH 1/1 switch port mode access switch port access VLAN 2 int ETH 1/2 switch port access VLAN 2 exit just to show VLAN. Blue VLAN has switch ports 1/1 and 1/2 as member. This switch doesn't care about the actual PCs. It's all about the physical switch ports. It doesn't know that this PC here, what it does, or this PC. It just says, this is a VLAN, and this port, 2 ports are associated with this VLAN. Okay. So config space T int ETH 1/3 switch port access VLAN. What VLAN? VLAN 3, yeah? Is that okay?
Yep.
Okay.
Yeah, good.
Okay, cool. So exit out, show VLAN, and that's what we have there. Okay, now you need to do the same with switch B, switch T int. Okay, so VLAN space 2, name is blue. VLAN space 3, name is red. Again, the names are only there for us humans. Switch is only switched by VLAN ID, by VLAN number. Okay, int ETH 1/1 switch port access VLAN 2, which is this guy here. So this port, this PC is on VLAN 2. Int ETH 1/2 switch port access VLAN 3. So PC4 is connected to 1/2 and is a member of VLAN 3, which is a red P, which was the red VLAN. Okay. Now to check, if I exit out of this, let me go back to switch A. And I do show VLAN. There's a problem here with this. If I move this up, do show VLAN, ETH 0/0, which is the trunk port, is a member of VLAN 1. That's a problem, because trunk links shouldn't be a member of VLAN 1. Trunk links, when you do a show VLAN, trunk links shouldn't appear at all in any VLANs. They shouldn't be there. So what we need to do is we need to configure E 0/0 as a trunk link. Okay, there's 2 commands to do it. I need to go into the ports interface ETH. Actually, let me just do a show here. Show int show switch port. Show int switch port ETH 1/1.
Isn't that 0/0, no?
Oh, it's 0/0. Yeah, my apologies. Sorry. So base switch port 0/0. ETH 0/0. That was. Okay. Show interface ETH 0/0. Okay. So you can see here what they do is they automatically. So I'm on ETH 0/0, right? And this switch A says I automatically try and determine the port. And I have this port down as being an access port. Now, this is not good. You shouldn't have, it's not, so you shouldn't have your trunk link, which is your most important link, set to dynamic auto. Just basically means you're going to leave the switches to auto negotiate which type of connection it is. And it normally defaults to access ports. And that's a problem because let me show you. If that's an access port, let's host PC3. Let's see if we can ping over here. 192.168.3.4. 3.4 even. It's not going to work because it's set up as an access port. So we need to change ETH 0/0 and create it as a trunk link. Cisco, the commands are quite difficult in order to do this. Don't need to know to learn the command. What you need to do is you need to go into ETH 0/0 and you need to say switch port trunk encapsulation .1q. So I want this to be .1q is the protocol, the trunking protocol for putting your VLAN tags on it. Okay. What .1q was this mechanism here? It adds the VLAN tags before it sends it across the trunk link, 802.1q. Does that make sense? And the second command is switch port mode trunk. Now let's do show interface ETH 0/0. Do show switch port interface switch port, and you can see ETH 0/0 again. It's enabled and it's a trunk link. See, that's what you want to have. The encapsulation is .1q. Now we need to do it on the other switch as well, switch B. Exit int ETH 0/0 switch port trunk encapsulation .1q switch port mode trunk. We'll do this lab tomorrow with Packet Tracer. There is multi-layered switches on Packet Tracer. So you can actually simulate a multi-layered switch, I believe. Yeah, this guy here is a multi-layered switch on Packet Tracer. So we'll do that tomorrow. So you can practice those commands in. Yeah. Okay, let's go back here. And PC1. So PC actually, well I'll go first to PC2. PC2 should be able to ping who? On switch A. It should be able to ping 2 and 5 should be able to ping each other. So ping 192.168.2.5. Now what I'm going to open up Wireshark. Start packet capture. And you can see the amount of connections coming in. We'll talk about CDP some other time. That's, yeah, it's important. Okay, so I'm going to rerun that. But I'm going to ping over here, 2.3. Yeah, ping 192.168.2.3, which is this PC3 over here. Does that make sense? 1, 2, 3, 4, 5. But because this is going over a trunk connection, PC Let me just do a snippet. So we're done a ping. So on here, we said we want to ping 2.3, which is a destination here. Yeah, this is your destination. This is your source. This is your destination. So what will happen is the frame will be built. So let's say the MAC address is PC2, so it's 2222. So the source MAC address is 2222222. Destination MAC address is, let's say it's a broadcast. FFFFFFFFFF. Well, it has to do with broadcast for the ARP. That will go in to the switch. The switch will send the broadcast out VLAN 2. So who gets it? This guy here will get it. But the switch then will say, okay, this frame also needs to go out the trunk connection. So I'm going to send it out the trunk connection. But before I do, I need to put in a tag to tell my best friend, switch B, that this frame is associated for VLAN 2, and it'll put it in here. VLAN ID with number 2 in it. Is that okay? So let's go back here, go to Wireshark. There we go. 802.1q, VLAN ID tag. This is extra piece of information put in on the frame. This is, you only see this coming in on a trunk link. You only see this coming in on a trunk link because it switches A's way of telling switch B only send this to ports associated with VLAN 2. Prioritize for priority. You can give what's known as quality of service, extra privileges, extra priorities to different VLANs depending on, it's for voice over IP and stuff like that. Does that make sense? Like if I and then you can see it, it's always going to be there. As VLAN 2, even so. Every packet that's going to go across a trunk link from A to B, the switches have to talk to each other. They have to say which frame this is going into by putting in a VLAN in the respective frame. So that when this frame comes in to switch B, B will look at it and go, okay, this is going to this MAC address, but it's associated with VLAN 2. Is there any questions on that, guys?
Is the extra information only put in on the trunk connection VLAN 2? It wouldn't normally put it in as just default at 0 all the time.
Right. Okay, there is another one. So, yeah, so access ports, they don't get it. Okay, because switch A doesn't need to tell itself that this is for VLAN. So let's say PC2 wants to speak to PC5, right? This guy here wants to speak to switch A, doesn't need to tell itself that this PC2 and VLAN and PC5 are in the same VLAN, because switch A knows that already because on its local switch. The reason we have VLAN tags is because switch A needs to tell a different device that this frame is otherwise is going to go to VLAN 2. Otherwise, switch B won't know what VLAN to send it out. Okay, so
Is the VLAN tag in the reply as well?
let's have a look. Yeah. Because switch B, it's a great question. Switch B needs to tell switch A the response. Yeah. I'm going to go through it again because let me just bring up another one here. Open with paint. So you got VLANs here. You got, let's say you got VLAN 2. We'll just talk about the red VLANs, okay? VLAN 2 here. So you got VLAN 2, VLAN 3, and VLAN 4. So you got red, blue, and green. Red, blue, and green, okay? So let's say we've got another red guy here as well. And this guy is associated with VLAN 2, okay? So this PC generates a broadcast message. So source MAC is 2222222. Destination MAC is FFFFFFFF. So this frame will go into switch A, and switch A will receive it and say, oh, I need to send this frame out my red ports. Any port associated with VLAN 2, because VLAN 2 is my red port. So it'll send it out. This, let's say this port here is port number 4, whatever. It'll send it out here. Okay. This guy here receives it because he's a red PC, and red PCs are in the same VLAN as VLAN 2. Yeah. Now, switch A and switch B know we've told A that it's a trunk connection. And basically, a trunk connection is a way of saying to switch A, the device on the other end of that port is another switch. So switch A knows that the device on the other end of this here, let's say this is port number, let's say 9, and 9 here. So switch A goes, the device connected to me is another switch, and that other switch may also have ports associated with VLAN 2. And switch B does have ports associated with VLAN 2. So switch A says, I need to send this broadcast message across my trunk link, because that's what trunking do. Trunk links carry multiple VLAN information between switches. But I need to have a way of telling switch B that this is a broadcast message. We have that, FFFFF, but only to go to VLAN 2. So it puts in your VLAN ID of 2, which is what we've seen when we run Wireshark in the middle here. Any questions on that then?
That's all good. But regarding trunking cables, obviously, if you've got 2 switches within the same cabinet, obviously you can use a copper, a Cat5 cable, or can use cascade leads.
You can, yeah, you can use any, you can use Cat5, you can use copper, you can use fiber, anything at all that connects in, as long as the port is configured for it. Yeah. So it doesn't matter, the switch doesn't care. So whether you use copper or fiber or whatever.
Or as in when you're designing the actual network, would you, obviously you'd have all the information beforehand regarding the actual VLANs, like, you know, would you segment the switches accordingly, or would you do it on site?
Well, yeah, well, I mean, it depends. It really depends. Like if I would, you know, like if I'm in a data center, you're going to be using Nexus switches, Nexus 9K switches, Nexus 7K switches are specifically for data centers, and they can be configured to do what's known as POPE, power on auto provisioning, where they get everything, all of it's configured automatically from a DHCP server, so you won't have to do any configuration. But if you were a smaller company, you could configure it on your desk and plug it in, and yeah, configure it on your. So if I was in a small to medium sized company, bring the switch up to my desk, open it up, power it on, configure it, put all the config on it, then bring it back down to the comms room, physically plug in everything in, and away it goes. I don't like being in comms rooms configuring devices unless I have to be, because they're not nice. They're not nice places to be in all the time. They're loud, they're cold, they're either too cold or too hot, you know, depending on what aisle you're in. So you're better off trying to configure it remotely and then connecting it in. But yeah, I would, but it's like anything though. Don't try and configure. You should have your config done and tested on it. Like, you could actually run a test environment on GNS. Like, these switches will behave the exact same way two physical switches, a 3560 switch, will configure in real world, because that's what they are. These are running off real operating systems. You know, whereas Packet Tracer won't. Like, if I let me just log in here and I'll show you the commands available in here. So this is a real switch with real commands. You could have a GNS lab where you could have 10 grand worth of equipment on this GNS 3 lab, network lab, with, you know, you could have a CCIE lab running here on GNS for nothing. Whereas years ago, before GNS 3, you spend 10 grand easy on kit, on hardware, and you have massive big electricity bills. You don't need it anymore. You can do this all here. And it'll operate the exact same way as two 3500 switches would in a cabinet somewhere.
Could you copy a config from GNS and apply it to a switch?
Yes. Yeah. Yeah. And we'll talk about that, how to set up commands and how to do that. Yeah. Very, very easy. It's only text file. Yeah. Okay. Let me just open up here. So here we have two VLANs, okay, on just a different sort of setup. We've got VLAN 15 and VLAN 1, yeah? So again, I really want, and we've got a chunk link between A and B, okay? So we have A here, and B here. So if we have a device on VLAN 15, generates a broadcast message, it'll go into the switch, and the switch will send it out its local switch first. A will say, okay, I'm going to send it to my local VLANs 15, and then, so the source MAC address, blah, 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 destination MAC address will be FFFFF, and then the switch will put VLAN 15 and send it across the trunk link. This switch, this frame will go in to switch B. Switch B is going to identify the tag and say, okay, this is a broadcast because it has FFFFFF, but it's a broadcast only to go to devices in VLAN 15. So these two guys will get it, because switch B knows that this PC is connected to a port associated with VLAN 15, and this PC is connected to a port associated with VLAN 15. Okay, switches do that for all ports. They put in frames for all ports except for VLAN 1. VLAN 1 is a special port, it's called the native VLAN. And with the native VLAN, it doesn't associate a tag. There are no tags associated with VLAN 1. Doesn't put in a tag. So what'll happen is, let's say we got a red PC here. Okay, VLAN, this PC in VLAN 1 generates a broadcast. Source MAC is A. Destination MAC address is FFFFFF. It goes into A. Switch A goes, oh, I better send this across to all the other ports associated with VLAN 1. So this port here is VLAN 1. This PC gets it. This port here is VLAN 1. The red PCs will get it. And then it says, I better send it out to trunk link. Okay. Switch A says, I better send it out to trunk link. But, oh, this is VLAN 1. VLAN 1 is the native VLAN. So I don't need, because VLAN 1 is my native VLAN, I don't need to put a tag on that trunk link. So this goes into switch B. B looks at the frame coming across. All frames coming across the trunk link will have tags, except for VLAN 1. So when switch B looks here, sees that it doesn't have a tag, it knows instinctively that this needs to go to VLAN 1.
Could you say your native VLAN is your default
Yes.
VLAN?
Yes. And another thing is they must match. You have to have native VLAN 1 here, and it has to be 1 there. If not, you're going to have problems. What would happen if native VLAN 1 was on A and B's trunk link there was native VLAN 15? What do you think would happen?
It
So-
would broadcast to 15 on B.
Yes, yes, exactly. That's it. It would go across into the trunk link. Switch A goes native VLAN 1, no tag. Then it would send it across. It would go into the trunk port on switch B. Switch B says no tag here. So therefore, I need to send it over to VLAN 15. And there you've got what's known as VLAN hopping, which is really wrong.
I take it you have to configure the switch to change it from 1 to 15.
You do, yeah.
Yeah.
And your switch will give you lots of errors. Let me show you. So to do it, config space T, like I can change it. Actually, there's a good idea. What I'll do here is, right, so we seen here, this was VLAN 2, yeah? So what I'm going to do is I'm going to configure native VLAN to be VLAN 3 on. So my native VLAN will be VLAN 3. So go into the switch, interface ETH 0/0, switch port, trunk, native VLAN 3. Then I need to go into switch B, do the same thing. Now, actually, what would happen very, very quickly here in a few seconds, let me just close this here, quit without saving. Oh crap, put back in here. Was ETH 0/0 into ETH 0/0. And what's going to happen is that should get error soon enough. So you do Wireshark packet capture. Maybe it's not configured, but the switches should be telling each other that this is there's a problem here. So show interface trunk. Show interface trunk. Native VLAN 3. Yeah, on A. Going to B. Show interface trunk. Native VLAN 1. There's a problem. So I want to change this guy here to native VLAN 3. Space T int ETH 0/0 switch port trunk native VLAN. So now when this PC pings PC4, because it's on native VLAN 3, there won't be a tag in it. So PC1, I'm going to ping 3.4. Oh, Why is that not working? Fixed base T int ETH 0/0, no shutdown. Fixed base T int ETH 0/0, no shutdown. Let's go into A again. Show VLAN. One slash 3 is on 3, VLAN 3. Yeah. And then switch B. 1/2 should be on VLAN 3. One slash 2 should be on VLAN 3. Yeah, that should be right. Let's check. Show IP. 192.168.3.1. PC4. Show IP. 192.168.3.4. Yeah, that looks okay. Try to ping that again. Let's do Wireshark. See if any pings going across. No, that's strange. So it's not even going across the trunk link. They're the old pings. That's very strange.
Does the VLAN need an IP address, Lee?
No, unless, what will happen is, let's say, for example, if, let's say the blue guys, right, are the IT team, okay? So they're in VLAN 2, okay? They're the IT department, right? And they should only have access to management access to the switches. What you can do is you can give a management IP address to VLAN 2, which will allow only the IT guys access to switches, because the VLANs on VLAN 3 won't be able to access it because they're in a different subnet. So let's say the red guys are in the sales team. They shouldn't be allowed telnet into the switch, because why would a salesperson have telnet access to the switch? Only the IT guys will have telnet access. So you could go into switch A, here, fixed base C, interface VLAN 2, IP address 192.168.2.9. And now, who will be able to ping 2.9? Who will be able to telnet in? All the blue guys. Would PC4 be able to telnet into the switch here? No. So the only time you assign a management IP address is for management purposes on a VLAN. So any questions on that?
Thank you.
Okay. I don't know why. Show. That should have worked. Native VLAN 3. See, the native VLAN now is matching. Yeah. Okay. We're going to go back over this again tomorrow anyway. Let me just close this up here. There's a few other things I want to talk about. We'll set up a lab tomorrow using that. So just multi-VLAN lab. Okay. So here's a similar same. So let's say we got multiple VLANs. Okay, so we got VLAN 2, VLAN 3, and VLAN 4. Okay. We got switch A and switch B. Now again, the VLAN tag, VLAN 4, look at the subnet. VLAN 2, 172.12.2.2. VLAN 2 on this side, 172.12.2.12. So the two devices on VLAN 2 are in the same VLAN, VLAN 2, but they're in the same layer 3 subnet. 172.12.2.2, 172.12.2.12. Look at VLAN 3, 172.12.3.1, VLAN 3, 172.12.3.11, VLAN 3. VLAN 4, 172.12.4.4 on VLAN 4, 172.12.4.14 on VLAN 4. Yeah. If I log on to the switches here, CLI, enable, show VLAN. This would be something like that you might get asked on the exam. It might give you something like this, and it might ask, say, what is the operational impact of this? So it's going to give you the output from here, and it's going to say, what is the operation? And it'll give you multiple choice. It'll give you different scenarios. Will, for example, as per this here, would the device in VLAN 2 on switch A be able to talk to the device on VLAN 2 on switch B?
No,
Why not?
there's no VLAN tag.
Okay.
Draw slash 24.
Slash 24. Yes. Where is 24?
Between the
No
switches.
VLAN, no trunk setup.
So slash 24 is seen. Let me just do a snippet here. Definitely easier when just copy this. Open Paint. Paste this in here. Okay, so let's just do colors again, right? So let's say blue is 2. Okay, that matches. So blue is 2, right? So this is blue. And this is blue, right? And let's say VLAN 3 is red. Yeah. And say VLAN 4 is yellow. Okay, so what port is our trunk link telling? So the switch says 0/24 is in VLAN 3.
You have one VLAN 3 in yellow there.
Oh Jesus, what happened there? That was meant to be red. That was just bad coloring. Red. Let that go yellow. And then yellow is here. Ah! Put this red. Okay. And then the next one was yellow. Okay. Something happened there. There we go. Okay. So /24 is what? What color? VLAN 3. VLAN 3 is associated with The red VLAN, yeah? So basically 0/24 is an access port. Some idiot, me, configured 0/24 as an access port, because when you do show VLAN on a switch, you shouldn't see the trunk link appear. The trunk link shouldn't even be in the VLAN. The VLAN database should only show you access ports. So that's there's like 0/24 should be nowhere. So the operational impact of that is 0/24 is configured as an access port. An access port can only be a member of one VLAN. In this case, it's a member of VLAN 3. So in this case, it's going to be the red VLAN. So what's going to happen? Will VLAN 2 be able to talk to VLAN 2? No.
No.
Because switches only provide communication between devices in the same network. You can't go from a blue network to a red network back to a blue network. Will VLAN 3 be able to talk to VLAN 3?
Yes.
Yes. So this guy in VLAN 3 will be able to talk to his opposite number on VLAN 3 because the access port or the trunk link, which meant to be a trunk link, is not a trunk link, is an access port and is associated with VLAN 3. Will the yellow guy in switch A be able to talk to the yellow guy in switch B?
No.
No, because you can't go across an access port and over here. So let's have a look at this. So I'm going to run a continuous ping. I'm going to go in here. Ping -t 172.12.4.14. So it's timing out, yeah? What about this VLAN 3? We said this should work. Ping -t 172.12.3.11. Yes. Yeah. Leave that pinging. And then we got VLAN 2. Ping -t 172.12.2.12. 172.12.2.12, and it's timing out. So we need to fix this because at the moment, like I said, at the moment, VLAN 3 is the only one that's working. So we need to go into FA 0/24. C interface FA 0/24 switch port. Now switch port and caps. This switch and packet tracer doesn't support encapsulation.1Q, so you can just simply go switch port mode trunk. On that end, go into the other one on switch B and say the same thing. Enable face-to-face T interface FA 0/24 switch port mode. So that's it. See what happens. Let's just do show interface trunk. That's how you see your trunk ports. And now you can see it. Trunking. If I do show VLAN, where is port 24? It's not there at all. Because port 24 is a trunk link, and trunk links are members of no VLANs. Their job is to carry all the VLAN information, but they have to remain objective. They can't be a member of any VLAN. That makes sense. It's kind of like a weird kind of I don't know. opposite kind of thing. In order for them to carry multiple VLAN information between the trunk links, they're not in here. When you do show VLAN, your trunk port will not be there. You want to find out your trunk port, show int trunk. Show interface to trunk. And that's it. And let's go back. Look, it's pinging. When did it start pinging? As soon as we configured FA0/24 to be a trunk link. FA0, that we had no issue here at all with VLAN 3 because FA0/24 was an access port on VLAN 3. That was never given us a problem. So you can see how important it is to have correct trunk links. Because if you have a trunk link that is incorrectly configured as an access port, then only that VLAN will be able to communicate between switch A and switch B. Now, if you didn't have any VLANs, well, then you're not going to have any problems, because VLAN 2, you know, because they're all going to be in the same flat network. Is that okay? All right. I'm going to show you this diagram here. We'll probably go through a little bit of it. Let me just open it up here. Yeah. Okay. One second here. Get a bit bigger. Okay. Let's say we had a PC here. So let's say we had a PC here, okay? And this PC is blue. And this PC's blue PC is the IP address of blue network is VLAN 2 and is 192.168.2.0 subnet. This PC is 2.5. Okay, and say this PC is red and is in the, and that's red, VLAN 3 is red, okay? To the red pen. So red, and the red is VLAN 3, and this PC's 192.168.3.5. Yeah. We've talked so far about this blue guy should be kept separate with this red guy. Yeah. But what happens if you want to, for them to be able to communicate with each other? Like earlier on, we said, let's say the blue guys, let's say the blue team is the students in a college, and the red guys are the staff. What happens? But the students should be able to talk to the staff. They shouldn't be able to kept completely separate. So what will need to be done in order to bridge the two VLANs together? So what you've done essentially with the switches is you've broken them apart. You've created two VLANs, VLAN 2 and VLAN 3. But what happens if you want to bridge them together? Well, then you can use a router. And what a router will do is it will be able to
different networks, yeah,
connecting to two networks together. Yeah. And you're saying, why would you do that? Why would you go through the hassle of dividing two separate networks using VLANs only to use a router and to have them pinging again with each other. But you see, routers are ideal for access control, for security. You can't do access control for security on a switch, but you can do it on a router. We will talk about access controls. So once you have everything going through the router, you can configure the router to say, okay, the staff will have access. Give the staff access to all the students' resources, but the students won't have access to the staff resources. And that can be all done through the router using access lists. And we'll talk about the configuration for that tomorrow. Because just yeah, there's not enough time. And that's on the way. So let me just